So this is a lesson for college prep. We are going to be starting a new section. This section is going to be based on linear equations and graphing, section 9. So this is really going to start getting into a lot of the algebra stuff and the graphing, and this tends to be an area that I notice that students tend to struggle with, so I want to make sure that we go over it and that you understand it so that you're able to find some success um, in these lessons and be able to understand this better so that when you go on to Algebra 2, you'll have a better foundation for the graphing of linear equations. So the first thing I want to look at is the coordinate grid. The coordinate grid system is broken up into 4 quadrants. Quadrant 1, 2, 3, and 4. It goes in a counterclockwise direction. So we go backwards on a clock that we would actually tell time on. And we have different areas of this coordinate grid that we're working with. In quadrant 1, we are working with all positives. So remember, along the x-axis, it's just like your regular number line. As you go to the right, you have all of your positive values. If you're counting up your y-axis, you would have all of your positive values up top. As you count to the left on the x-axis, you have your negative values, just like on a number line. And if you're counting down the y-axis, you have your negative numbers here as well. Your origin is your center. So that means that it's at 0, 0 when x is equal to 0 and y is equal to 0. So in quadrant 1, your x's are going to be positive, your y's are positive. In quadrant 2, your x is negative and your y is positive. Quadrant 3, x is negative, y is negative. And in quadrant 4, your x is positive and your y is negative. So now remember, whenever we graph, we are always going to start with the x coordinate on the x-axis. Okay, and then we are going to move from the x-axis to the y-axis and graph your y coordinate. Okay, so you're always going to start on your x, graph your x point, and then go up to your y. Remember, you're going to have just one single point. So if I gave you the point of 3, 2, we are going to start on the x-axis, and we are going to go over here, 3 units on the x-axis, which is right here. And then we are going to go up 2 units to right here. And then we would label this point of 3, 2. Okay, so feel free, you can use a separate color if you want, a highlighter, a colored pencil. You can count over your units and then up your units to show that you understand your x is always graphed first, and then your y, and you want to label those points that are on your graph, because without the labels, we don't really know that you've put things into the right spot. So you want to make sure that you label them, okay? Same is true if I gave you the coordinate point of -3, -4, again, we start at the 0. Always go back to the origin to start. And we're going to go over -3. So we go over 3 units on the negative side. And then we come down 4 units. So we come down 1, 2, 3, 4 units here. Put a point. And then we label that of coordinate point -3, -4, so that we know what the point is. Now, you want to make sure you label it. You want to make sure you put in a solid dot in order to graph that point. If you don't have that solid dot, it kind of makes it difficult to understand or to see that you've graphed the point. So you want to make sure you have that dot, and eventually we will connect those dots, multiple dots, to make a line. Okay. The other thing to remember is that when you're given multiple points, we call those a relation. And every grouping of coordinate points creates a relation. And we're going to talk a little bit later about special points that create a function. But every grouping of coordinate points will create what we call a relation. Okay. On the next slide, we are going to be plotting points, and this is what we just described, okay? So a point is a location on the graph. It's in the ordered pair of X and then Y. So the math terminology that we use is called ordered pair. And this explains exactly what I just explained and showed on the last page with the example of graphing that. So you guys can have this for your notes and read through that later. When we graph a line on a coordinate plane, there are 3 different ways that we can graph that line. The first is to make a table of values and points. So if I give you an equation and I give you the X values, you can substitute the X values into the equation and solve for Y, and that will give you your Y coordinate, and then you just plot those points, and we'll see that in one of the assignments. Intercept method. So the intercept method, let's do this. The intercept method just explains how you are graphing the point. So if I cross, the intercept is where the line of the graph crosses the axis. Okay, so we have 2 intercepts. We have the x-intercept and we have the y-intercept. Okay, when we cross at the x-axis, we are saying that our y value has to equal 0. And when we cross at the the y-axis, we have to say our x is equal to 0. Okay, so our intercepts. So that would be if I had a coordinate grid, and it looks like this. So we have our y-axis, and we have our x-axis. And then if I am talking about the intercepts, if I have a graph that looks like this, what I'm looking for is I'm looking for where does it cross. So this is the x-intercept where the line's crossing the x-axis, and this is the y-intercept where the line's crossing the y-axis. So we want to make sure that we find those. So at this point, we know that y is equal to 0. So y has to be equal to 0. And we can see that because if we're at the origin, y has to be equal to 0. It's nowhere on the y-axis. Over here, when we're on the y-axis, we know that x has to be equal to 0. And we can see that when we look at the graph because we notice that here's the x-axis. We're at the 0 point and we came down to the y. So we know that x has to be equal to 0 there. So that's why we call them intercepts, where they intercept on the coordinate grid. And then the last thing that we're looking at is we are looking at this y equals mx plus b. This is a formula that many of you are probably familiar with, and you've probably used it many a times. It's called slope-intercept form. Okay, where y is your y coordinate, m is your slope, b is your y-intercept, x is your x coordinate. So y is the y coordinate, m is your slope, x is the x coordinate, and b is the y-intercept. Now remember, the key pieces that you want to be aware of are the slope and the y-intercept. Remember, y-intercept is where the line is crossing your y-axis. The slope tells us how the line is moving. So it's the rate of change, how it moves from one unit of measure to the next along the x-axis, okay? The y-coordinate and the x-coordinate are often just variable pieces that we don't know the value of until we solve. So y equals mx plus b is our slope-intercept form. And our key pieces we want to know are the slope, m, or b, the y-intercept. All right, so a line is made up of multiple points connected together. Typically, the rule in order to graph a line is you must have a minimum of a minimum of 2 points in order to create a line. Typically, you're going to be asked, and you're going to see a little bit later, that you're going to have multiple points in order to graph that. All right, every line on a graph has corresponding equation. So the graph of a line is just the visual representation of the answer solution to the equation. So every equation has a solution. Every equation has a graph that goes with it. So we're going to be working with the graphs and seeing the solutions. Standard form is one of those things that we see a lot in algebra, and standard form shows us ax plus b equals c if we only have one variable. If we have two variables, ax plus by equals c. And this tells us a, b, and c are all real numbers. A and b are not both equal to 0, and it's a first degree polynomial, which means that there's no exponents. So we are going to be working primarily with ax plus by equals c, and we can turn that into a y equals mx plus b just by moving the variable pieces. So we could subtract the ax from both sides and then divide both sides by b in order to get to our y equals mx plus b. We're going to see that a little bit later in a couple of our things. All right, so a solution is numbers that make the equation true when they're replaced when they replace the variables. So you're going to see that if we have any numbers, any coordinate points along a line, that coordinate point should be a solution to our equation. So if we take the x and the y value and we substitute it into the equation, we will get a true statement for that equation. If more than one equation in a linear system, the numbers that replace the variables must all make the equation true. This is going to come in play a little bit later when we have the systems of equations. So you're probably not going to see it much right now, but you definitely will see it when we do systems of equations. Now, the assignment that you guys have for today, you have two things. One is this assignment 9.1. And this has all the assignments you're going to do. Horizontal and vertical movement. Horizontal is along the x-axis. Vertical is along the y-axis. So in this case, horizontal 3, vertical 2. So you're just stating where your x and your y are, and we're just using some different wording. This one, you're just going to be naming the coordinate pair. Remember x first, then y. And then here you're going to plot the point, and then you're going to tell which quadrant. Remember, it goes counterclockwise. 1, 2, 3, and then 4. And then this one, I started doing it before. So we're going to rewrite the equation in the function notation, x minus 3y equals 9. So if I start with the original problem, it's in standard form. Remember that ax plus by equals c. I need to put it into y equals mx plus b. So I subtract the x from both sides, and I get a negative 3y equals negative x plus 9. I'm going to divide everything by a negative 3. So each of the terms are going to divide it by negative 3. So this divided by negative 3y divided by negative 3 is going to become a positive y. Negative 1x divided by a negative 3 becomes positive because negative divided by negative becomes a positive. So it becomes 1/3 x. Positive 9 divided by a negative 3 becomes a negative 3. This wants me to write it in function notation. Now, earlier I told you that every set of coordinate points is a relation and that there's a special situation when it's a function. So the special situation for functions mean that there are no repeating x values. If there's a repeating x value, it's not a function. But in algebra, we can tell you that you're dealing with a function. So you're dealing with that situation of no repeating x values by replacing the y with this f parentheses x. And we read that as f of x. Okay, so f parentheses x is equal to y. It's the same thing. They're going to replace the y with this f of x. That is just determining and telling you and naming the equation a function so that we know that it is a function and that we have the ability to know that there's no repeating y values, okay? And then this here, you are just going to go through and you're going to substitute the values for x into the equation. So our original equation is y equals 6x minus 9. I want to take y equals 6 times negative 2 minus 9 and substitute the value. And then I want to do the same thing for negative 1, 0, 1, and 2. So you're going to want to make sure you use up your space and you write this information in. Okay. The other assignment that you have for today is going to be graphing points. And it is the punchline 7576. And what you're going to do in the top one in 7.5 is you are given the values for x. So you're going to substitute them in, solve for y, and then you're going to graph. Now remember, I don't really care about the solutions to the problem, to the joke. I want to see your work. So I'd like you to grab a separate sheet of paper, do your calculations out for each one of these, numbering them nicely so that I can see them, filling in the values for y, and then graphing, and graph each one of these. And like I said, I don't really care about this answer. If you want to do it, you see these letters around the outside of the coordinate grid. It's wherever the line goes through is going to be where the letters go in. On the second sheet, 7.6, what you're going to do is you are going to use the intercepts. So this is where we make x equal to 0, solve for y, make y equal to 0, solve for x, and then you're going to graph the coordinate points. So if I plug in a 0 for x here, I get y is equal to 4. So then I would put a dot on the positive 4. So I'd go over here 1. Well, I said y is equal to 4. So I'm going to go up here 1, 2, 3, 4 here, and I'm going to put a dot. And then I'm going to say, okay, well, if I put in a 0 for y, I'm going to get x is equal to 4. So I'm going to go over here, 1, 2, 3, 4. And I'm going to put a dot right here. And then I'm going to take and I'm going to connect the dots with a line. And we want to extend the line through the points. Okay? And typically we should have an arrow at either end showing that this line continues on and on and on. It doesn't end. Okay, so you do not want to just put the line in between the two dots, because then that is just a segment and it's not a line. Remember, back to your geometry, we want to make it a line, which means that it has the arrowheads on either end of it, so it continues on forever. So that's today's assignment, and that includes all of the work that you're going to do. If you have any questions, please make sure you either reach out to me. You can send me an email. You can talk to Colonel. You can talk to Mr. Conley. You can talk to Miss Angelini. You can talk to Mr. Hastings. You can talk to Miss Johnson. Most people in the math department, everybody in the math department will be very helpful. There might be some other people in the building that you can ask for help if you need it, but please do not be afraid to reach out and ask for help. Send me that email and we can always schedule a time either during your study hall or maybe after school if you have time after school, and we can meet here in the Zoom room and go over any questions that you might have. We can also pull up these assignments and I can work through a couple of the assignments with you if you have any questions. So please do not be afraid to reach out and ask for help if you need any, okay? Other than that, I am all done with you now. I'm going to let you go and get started working. I know it's a shorter day, so some of this work will carry over. All right, talk to you later.